Welcome friends to my YouTube channel. Now in my previous lecture I have told about the motion of an object through a tunnel on earth. Okay, motion of an object through a tunnel on earth, and there we find that the time period of oscillation is approximately 84 second. Okay, approximately 84 second. Now in our today's lecture I shall going to discuss about simple pendulum. Okay, we are going to discuss about simple pendulum. Okay, now what is a simple pendulum? The first question that arises, it is simply a weight suspended from a pivot, suspended from a pivot. Okay, it is simply a weight suspended from a pivot so that it can oscillate freely. Okay, it is simply a weight which is suspended from a pivot so that it can oscillate freely. Now if we draw a picture, then this is the pivot. Okay, okay, this is the pivot. Okay, from which the pendulum bob is suspended. Okay, now this is the equilibrium position, say O. Okay, so the pendulum oscillates about this. Now suppose at any instant the pendulum bob moves from O to this point. Suppose this distance is x. Okay, at any instant the pendulum bob occupies this position. Okay, say this is A point, say this is B point. So at any instant the pendulum bob is located there. Now pendulum bob of mass m. So at this point the weight acts along the downward direction. Okay, the weight acts along the downward direction. Okay, so this is the angular displacement theta. Okay, and one thing must have to remember here, the angular displacement theta, angular displacement theta is obviously taken less than 4 degree. This approximation here we have to use. Okay, the angular displacement must be less than 4 degree. Okay, so since this is very small, this and this is same, so if the length of the bob is L, it will also L. Okay, so if we resolve it into two components, then one component is this and another component is this. This is theta, that means this angle is also theta, and we can write this as mg cos theta. Okay, and this is mg sin theta. Okay, similar angle. So this is mg cos theta and this is mg sin theta. Okay, so at B, weight mg acts in the downward direction. Okay, so mg can be resolved into two components. Mg can be resolved into two components. Okay, the mg cos theta that balances the tension obviously, and mg sin theta tries to bring the bob into its original condition. You all know it. Okay, that mg sin theta tries to bring the bob into its original condition or original position, and mg cos theta obviously balances the tension. Okay, so mg cos theta balances the tension, whereas mg sin theta tries to bring the bob into its original condition. Okay, mg sin theta tries to bring the bob into its original condition. Okay, fine. Now let us see what is the equation of motion. Okay, what is the equation of motion? So obviously this is the restoring force. Okay, this is the restoring force. We give here minus sign because the negative sign and indicates that the force is restoring. Okay, so minus sign indicates that the force is restoring, obviously. Now what we can write, if the equation of motion of the bob we can write as m into its displacement from equilibrium is x, so m into acceleration d2x dt2, this we can write as minus mg sin theta. Okay, so cancels. Okay, fine. So this will be d2x dt2 equal to or minus g. So here theta is very small, so therefore we put theta instead of sin theta, since the angular displacement is always less than 4 degree for a simple pendulum. Okay, so what will be my theta? X by L. Okay, so the equation is d2x dt2 plus omega square x equal to 0, where omega is the angular frequency of oscillation that we all know, g by L to the power half. Okay, so omega is the angular frequency of oscillation that we all know, that is square root g by L. So once we find omega, we can easily calculate the time period of oscillation. Okay, so this is the case. Once we find omega, so we can find out easily the time period of oscillation of simple pendulum. Okay, so obviously that is t, 2 pi by omega, that is 2 pi L by g to the power half. So this is the time period of oscillation. Okay, so we can easily conclude the pendulum laws from this expression. How? That first of all we see that when g is fixed, then time period of oscillation is directly proportional to square root of L. Okay, when g is fixed, t is directly proportional to root L. Okay, for g fixed, and from this equation we also see that t is proportional to 1 by root g provided L is fixed. Okay, when g is fixed, t is proportional to square root of L. That means time period of revolution is directly proportional to the square root of the length of the bob, and inversely proportional to the square root of acceleration due to gravity. And another thing is that there is no mass term in this equation. That means t is independent of the mass of the Okay, so these are known as the pendulum laws. Okay, so these are called pendulum laws. Okay, so fine. So this is what is simple pendulum, and we see that the motion is simple harmonic. Okay, and we also discuss about the laws of pendulum. Now let us come to another issue, that is the uses of this pendulum. Okay, so in which field the simple pendulum is used. At first we are going to discuss it. So we can use it in order to find out the acceleration due to gravity. Okay, the first use is to find the g of a place or at a place. Okay, to find g at a place, that means in order to determine the acceleration due to gravity at a particular place, we can use this. How? We easily know it. T equals to 2 pi l by g to the power half, or t square, this is simply 4 pi square l by g, and this is simply g is what, 4 pi square by t square into l, or more commonly we can write as this. Okay, so by knowing the time period of oscillation and length of the pendulum bob, we can easily determine the acceleration due to gravity. Okay, so this is the first use, that we can easily find out the acceleration due to gravity of a place. Okay, acceleration due to gravity of a place. Now another use is that to determine the height of a place. Height of a place. How? Okay, we all know that the acceleration due to gravity at the surface of earth can be written in this way, and that at a height h from earth's surface can be written in this way, that we all know. So from which we can easily write gh by g, this is simply r square by r plus h whole square, that we all know that acceleration due to gravity at a surface of earth is this, and that at a height h from earth's surface is this. So gh by g can be written in this way. Now t is 2 pi root l by g, that means when g changes, t changes. So let us suppose that when acceleration due to gravity is g, then time period is t, and when it is gh, say time period is t dash. Okay, so what will be the corresponding formula? That is t is 2 pi square root l by g for a fixed length. Okay, and t dash 2 pi root l by gh for fixed l. Okay, so from which we can easily conclude what is my t by t dash. T by t dash will be what? Root over gh by g. Okay, so obviously from which gh by g can be written as t square by t dash square. So substitute this value in this equation. Okay, so what we get if we substitute this value? So t square by t dash square, this is simply r square by r plus h whole square. So simply t dash by t r plus h by r. Fine, so this is simply 1 plus h by r. Okay, so this is h by r, this is equal to t dash minus t by t. So what is my h? R upon t, t dash minus t. So this is how, by using the concept of, by using the simple pendulum laws, we can easily determine the height of a particular place. Okay, so these are the basic two uses of simple pendulum. Okay, so This is up to what today. Now in my next lecture I shall going to discuss few other issues related to pendulum, and later I will move into the gravitational potential by taking suitable examples. Okay, so if you don't subscribe my channel, then kindly subscribe it to get latest videos on classical mechanics and physics. Okay, thank you.